In this K8 installation training video, we will cover the following topics: entering our installation parameters using our installer laptop, coarse pointing, fine pointing, and pointing validation. We'll conduct an on-site validation tool test. We'll activate the customer, and then assist the customer with installing the customer service tools. To install the HN9000 satellite modem, we need to launch Mozilla Firefox and enter 169.254.0.1 in the URL field for the older HN9000 modems. If you have one of the newer HN9000 modems, please enter 192.168.0.1. Upon entering that URL, the System Control Center, as shown on the screen below, should appear. To continue with the installation process, please click the little wizard icon, which is a shortcut to the advanced page. At that point, it should instantly go to the installation parameter screen, and it will ask for a terminal site name, the A code, B code, C code, U code, and latitude and longitude of the satellite system. The terminal site name is found on the field service order as a master account number. It usually starts with the letters DSS. In our example, because it is a training system, it does not have the normal designation. Next, you'll see the A code that says satellite orbital location. Our satellite is located at 95 degrees. Once expressed in 7 digits, it becomes 949505. Please choose this from the drop-down menu. Do not enter your own value. Next, you will see the B code. That's the antenna size. The antenna size could be a 0.74, 0.98, 1.208, and 1.804 size dish. All residential installs will use a 0.74 centimeter dish. The ODU power is expressed in 6 digits, but is commonly known as a 1 watt, 2 watt, 4 watt, or 10 watt transmitter. All residential installations use a 1 watt transmitter, so please pick the 103 designation. Next, you will see the U code. We only have one satellite currently located at 95 degrees supporting HughesNet satellite communications, so you'll need to select A as that being the only current satellite operable. Next, you'll have a latitude and longitude expressed in degrees, minutes, fractional minutes. This needs to be taken from your GPS. It is not acceptable to use mapping software, as when you enter an address, it may be more than 45 feet away from the location of the satellite dish, which will cause you to get a probing failure. The probing failure can be a result of many issues, so therefore you won't know it's the GPS specifically or the lack of a GPS that's causing the error. So always use a GPS to ensure that's not the issue if you come across a probing failure. Next, we're going to go ahead and enter those. And I've taken the liberty and written them down from my GPS already. And next we need to hit the Submit Installation Parameters button. At this point, a warning may come up telling us that the numbers entered need to be adjusted by 0.001 to make them consistent. If that appears, you would just hit the OK button and hit Submit again. In our example, that did not happen. Either way, next it should take you to the actual pointing information screen. At this point, please notate down your azimuth, elevation, your tilt angle, which is also known as skew, and the setting for your ODU polarizer. The polarizer is what's attached to the feed horn and allows it to accept either right-hand circular polarization, which is shown on the screen here, or left-hand circular polarization, which would be LHCP. It also puts the antenna size and the ODU power on the screen so you can verify that it was put correctly in. And then to your right, you will see a signal strength indicator to let you know whether or not you have signal strength. At this point, we need to go out to the DAPT and perform coarse pointing, followed by fine pointing, and then the last step would be antenna validation. The last step of intent validation is where you actually use adapt with the buttons to store the values of your squinting process, otherwise known as dithering. That method will allow to make sure that you're receiving the center of the beam and that you are getting an adequate signal so that you can go ahead and register the HughesNet HN9000 onto the HughesNet network. So that's what we're going to do at this next step. Okay, to begin the pointing process, the first step that we did was to preset the elevation, the tilt angle, and the polarizer according to the pointing parameters given by the installer laptop. The next step is that we put the DAPT in line on the receive side, going from the IDU to the LMB with the DAPT in the middle, and that allows us to communicate with the laptop and not have to walk back and forth to the laptop. So we're going to be able to use the buttons on the DAPT to go forward in the pointing process. The first step is we should see an IFL voltage. The voltage range should be between 11 and 15, and as you can see in our example, it's giving us 12.6 volts DC. If it gives a reading of 48 volts, you've put the DAPT on the transmit side and it will not work on that side. You'll need to remove it and reapply it to the receive side. The first step is to hit button 3. It will show the DAPT version number. It will say COM startup communicating with the laptop. It'll show logging the voltage measurement, and then it goes directly to point S. Point S refers to the short filter being used, which means you get almost a real-time display of the satellite signal. The numbers on the far left are the highest ever achieved. The numbers on the right are the current value. So if we were to get a satellite signal, the number on the left would reflect the highest signal we've seen. The number on the right is a current value again. At this point, we're ready to sweep the sky for azimuth, looking for the signal. Moving the dish to the left or right to find the signal. And that's what we're doing right now, and as you can see, we're peaking the signal. In this particular area, to get up in the 180s would not be uncommon, which is about the cell average for this area. Now that we peaked our signal, we need to tighten down the 3 azimuth bolts all the way. This time the tilt angle should also be all the way tightened down. The only adjustments that we're going to be making for fine pointing is to elevation and azimuth. And we're going to use the fine azimuth tool and fine elevation tool to do this. To begin, one of the things that we need to do is we need to tighten all the way down the fine azimuth bolts and then back them off 1/8 of a turn. That will allow us not to have the bolts too tight that may prevent it from turning properly, or too loose that will require you to start over again. Now that we have loosened the fine azimuth bolts by 1/8 of a turn, we're ready to begin the fine pointing process. This involves using a squinter to find the center of the beam, and the squinter is specific to each feed horn. Shown here is the A squinter, which is for a Prodlin oval feed horn, and here are the clips that attach to the actual feed horn. So we're going to go ahead and clip that on. We're going to start with the opening on the left side. It's very, very important to be consistent and always start and use the squinter the same way each time. Here we're starting the fine pointing process, and you'll see that the squinter has the opening to the left, and we need to take the first reading, and you can see that we've done that. On the squinter it's showing a 95, 96. And now we need to move the squinter 180 degrees, make sure it's level each time, and we're checking the azimuth on the right side now, and it's showing a 101 So that indicates that we're going to need to make a small adjustment to the fine azimuth adjustment bolt. And we're going ahead and doing that and watching the DAPT. We can see the numbers coming down to meet within 5 points. So we're right now about 1 point away. The next step is we're going to check the elevation. So now we're going to put the opening to the top and we're going to take a reading. And here we can see the signal looks about the same as it did on azimuth. So now we need to check it at 180 degrees. So we have about a 95. And check at 180 degrees and see if we can get the two to be within 5 points of each other. So that now shows 102. So we have about a 7 to 8 point difference, 102, 103. So we're going to make a small adjustment to elevation to bring that number down. And meet that value in the middle. And we'll go ahead and check it 180 degrees again on elevation to make sure that that adjustment brought it within 5. And it does look like, yes, we got it within just a couple points. Now, one final test, we're going to check the azimuth again, because whenever you make an adjustment to a dish with a tilt angle involved, whenever you adjust either elevation or azimuth, it affects the other. So we should always double check it. And we can see that value is just a little bit higher, so it did have an effect on it when we adjusted the elevation. So now we can see just a small adjustment needs to be made on azimuth. And basically what we're doing is we're narrowing down to the center of the beam. It might take a couple adjustments on each side. And again, we're checking the other side to make sure that we, in fact, did get within 5 points. I can't stress enough how important it is that the mount is level. If the mount is not level, making these 4 values meet becomes very difficult. And there we can see we got it within 5. Now that we've completed the fine pointing process, we're ready to begin validation. To do so, press button 3 on the DAPT. Center 1 is indicated, letting us know to remove the squinter from the feed horn. Press button 3 to capture this value, which will be stored in the DAPT. Squint as 1 now shows, so we need to rotate the squinter and make sure it's level, and then press button 3, storing the value. Squint as 2 appears now. Rotate the squinter 180 degrees, making sure it's level, and then press button 3. As test pass is indicated, we now hit button 3 to continue. If as test fail had it been shown, we would hit button 1 to start over the fine pointing process. Now that squint elevation is showing, we need to rotate the squinter to elevation 1 position, and then making sure it's level, and then press button 3. Squint elevation 2 now shows, so rotate the squinter 180 degrees, making sure it's level, and then press button 3 on the DAPT. Elevation test pass is indicated. Press button 3 to continue. It now is asking for a center reading. Remove the squinter from the feed horn and press button 3. Store results now shows. Press button 3 to continue. It then asks you to hit button 3 to indicate yes, you want to store the results. And that transfers the information from the DAP to the modem. Now pointing exit is indicated. Hit button 3 to continue. Pointing done should now show on the display, indicating you are done with the validation process. If you look carefully on the screen, under current SQF, you'll see the values changing. That is happening because one of the installers is conducting fine pointing and verifying that the azimuth and elevation are within 5 points. We will know when they finish the validation process because this screen will change to a status screen showing the steps of registration. We will reach state code 25 when the unit is fully registered on the network. Right now we're at state code 10 waiting for antenna pointing to complete. As you can see, the screen is now changed to the terminal initialization sequence. This is actually the HN9000 registering itself on the HughesNet network. It has completed downloading the commissioning software in a very short period of time after they hit button 3 in the DAPT indicating pointing was done. It will now turn on the satellite uplink signal and perform probing, which is the process by which it checks the power levels and the timing to set itself correctly based on our GPS location. If a screen such as this appears, just hit the refresh button. The modem may be rebooting at this point, and within 30 seconds it may come back up. Now we've reached state code 12. The downlink is established in commissioning phase, and the unit will continue working to state code 25. As you can see, we reached state code 13, and now finally probing is in progress. If probing were to fail, it could indicate that you put in bad GPS coordinates not within the recommended range of 15 meters. You would have to then go back to the installation screen and change the parameters to the correct values before continuing. We've already reached state code 18. It will have one more big software download to complete, called the operational software. As long as everything goes correctly, you should not have anything you need to click on. You should basically just be monitoring the progress to make sure it reaches state code 25. Here we can see the operational software is being downloaded. While we're waiting for the software to finish downloading, I want to point out that under max SQF during auto crosspol, we show a 171, showing that our signal strength during that testing showed a high level of signal, and that we should be able to see our SQF at azimuth 1 and azimuth 2 position, and again they're within 5 points, as well as elevation 1 and elevation 2 are also within 5 points of each other. At this point, we've reached state code 25, and in parentheses, you'll read the terminal is now fully operational. That concludes the registration of the modem on the HughesNet network. Now to continue with the installation, we will need to click the Home button. At this point, it will take us back to the System Control Center, where two links are indicated in red. We have an Activate link that's done on the customer's computer, and a Validate link for the installer use only. You must always click Validate first. Validate allows you to use the OVT tool, the on-site validation tool, to qualify the installation. It checks the quality of the installation by monitoring different values. So to do that, we're first going to click the Validate link. After clicking the Validate link, we are redirected to the installation portal. We'll now need to log in as an installer by clicking the Installer Login Click Here link. Enter your installer ID number as your username, followed by your password, then click Login. Now we need to go to Site Diagnostics On-Site Validation Tool, KAKU, and click the link. Enter our SAN and service order number taken from the installation reference sheet. The SAN will usually begin with the letters DSS, but in this example, we are using a test account, so it will start with the letters TAH. Then click the Launch button. At this point, it is giving us our information such as visit type and the SAN installer name, installer ID, and FSO. Please make sure the information is entered correctly and click Submit. The test is now running. It is actually polling the modem and testing the values given over the satellite link, and it presents us with the following information. First, if we're looking towards the top, where it shows the SAN, site ID, and electronic serial number, underneath that you will see a heading called Uplink Attenuation. The value shown is 2.8. That is significant to our uplink power word value. The first thing I will point out is that if we look at the table with the colored values showing target values, current values, and difference, the time we ran the test, which was just now at 10:54 a.m., and then the uplink power word showing a target value, what our current value is, and the difference. Notice the difference is shown in green. That is a passing value. That is indicated because the target values show a range and our current values are within that range, giving us a positive difference. If we now go to the next column, we will see an SQF value target of 163 and our current value is 179. The difference is a positive 16, again in green, indicating we passed that result. Then it will show a CONUS signal to noise ratio, again showing a target, current value, and a positive difference, an uplink signal to noise ratio, also with a positive difference, and a point-to-point signal to ratio, also with a positive value. Now, if any of those values were red, it could indicate a problem with the system. Most likely, it could be a pointing issue, or it could result in bad hardware and need replacement to be able to run the test again and pass. We are not able to complete the installation until we have a valid passing OVT, resulting in a sign-off code that we write down on the work order. Now, there's a few things I want to point out while we're looking at the screen that are very important when we're running this test. First, if we go to the third column, you will see the column heading shows downlink cell ID 66. That refers to which downlink cell the customer is in, and it shows an average cell SQF of 178.08. That means for the other customers in that area, the average signal strength or signal quality factor was 178. If you go to our SQF column in the table, you will see our current value shows 179. That means that our pointing has been done on average within 1 point of the average cell SQF. So that shows a very good pointing was completed. Also, you will see an uplink cell ID. That uplink cell contains 7 downlink cells, and in that uplink cell, the average uplink power word is a 35.61. Now, if we go to our uplink column in the table on the screen, you will see our current value shows as 38.2. Now, upon first glance at that, we might indicate that our pointing or uplink power word is not done as well as the average uplink power word, because a lower value down to close to the 31 range would be the most efficient value we could get, meaning the modem does not need to work as hard to keep the connection. However, there is a value that I pointed out earlier called uplink continuation in the first column, and that 2.8 is significant. The closer to 0 would indicate the center of the cell. The farther away from the center will increase the uplink attenuation value in the top range is above 5. So if we are at 2.8, we are almost halfway to that top range. So that would indicate that our current value will be a little bit higher than the average uplink power word because we are farther away from the center. So if we were in a center of that cell, we would most likely be closer to that 35 value. To verify this, we can simply launch another browser, bring up the target RF value page. Now this website is shown above. If you bring up this site, it does not require a login or a SAN to run. You simply can put in the customer's address, and I'm putting the address and zip code of this antenna, and I'll click submit, and then we can see the cell that the customer is in. So this is showing uplink cell 5, and we can see that we are away from the center of the cell as indicated by that red marker, and it indicates, if we click on it, it will indicate what the minimum target SQF is, what the maximum power word should be, as well as the uplink polarization setting, which would be for the polarizer, and that shows right hand. So we can see that our values are in fact very good. We have an SQF of 179 compared to 170 minimum. We also have a uplink power word value of 38.2, which is a little bit better than the 39 shown on screen. That is how we can view the OVT and get a real example of not only why a unit would be passing or failing, but how to interpret the results to make sure the customer has the best pointing we can possibly give them. Now, if anything was failing and showing red, there would be a box that would appear under where it says current diagnosis OK, and it would appear down here at the middle, and it would tell us the steps to do to try to correct the error. So we would go ahead and follow those steps. We would then hit repaired once we've repaired the issue that causes our values to fail, and then we would hit get current stats again, and it would rerun the test, hopefully passing that second time. Then we'd be able to click the sign off link. Now I'm going to go ahead and do that to show you what the sign off looks like. And basically it asks us what actions do we need to do to make this unit pass. In the first example I gave, we had no problem, so we would just click the no problem link and save and get sign off code. If we did have a problem, such as having to repoint or a radio or IDU failure or any of the other problems listed, we would simply check mark that box, add any additional information if requested, and then hit save and get sign off code. I will go ahead and do that and show you what the sign off code looks like. So at this point, it's put up the sign off code, both at the top and bottom, and then we would write those down on the indicated box on the installation reference sheet. So basically, that concludes the OVT process. Now that we've completed OVT, we need to bring up the System Control Center on the customer's computer by going to their browser. Once the browser's up, we can simply type in systemcontrolcenter.com and it will bring up the System Control Center. Now the next step is to click the Activate link. You should then see the subscriber agreement on screen. The customer should sit down at the computer and should be the one to read the subscriber agreement and accept the terms of the subscriber agreement. The installer may not do this on behalf of the customer. So once they've had a chance to read through the agreement, they should click I accept and then the accept button. It will then ask for the SAN and PIN. You can assist the customer by showing them the SAN and PIN on the installation reference sheet. Again, that will begin with the letters DSS, but for our training purposes, ours will be different. The PIN number will also be found on the installation reference sheet and is typically the last 4 digits of their phone number. Once they've entered those numbers in, they should click Continue. It will then welcome the customer by name. It will let them know their account is registered for service and give them an option to write down their SAN, their terminal IP address, and their terminal subnet mask if they need it for networking. At that point, they need to click Continue. It will then begin the HughesNet activation.